Hello everyone, welcome to ACE Online and ACE Engineering Academy. I am here going to discuss about ISRO exam, especially for mechanical stream. And in the mechanical stream, I am going to explain the previous year questions and with the detailed solutions, especially from the material science subject. See, myself, Madhushekar, faculty at ACE Online and ACE Academy, and I did my MTech from IIT Roorkee, and I am expert in material science, production, some ESC topics. Now, if you talk about the syllabus of mechanical engineering, okay, if you talk about the syllabus of mechanical engineering, especially from the material science, there are different topics here. They are, the first one is crystallography. First one is crystallography. From this crystallography, they will ask you questions from structures, especially. They will ask you questions from crystal structures like a simple cubic structure, body-centered cubic structure, face-centered cubic structure, diamond cubic structure, and a hexagonal close-packed structure. Crystal structures like atomic packing factor, the number of atoms, and coordination number examples. Same way, from the same unit, they will ask you the questions from the Miller indices concept. They will ask you the questions from the Miller indices, and they'll ask you questions from the defects like point defects, line defects, like you can take the Frenkel defect, Schottky defect, vacancy defect, and also dislocations, edge dislocation, and screw dislocation, they'll ask you. And sometimes they may ask you questions from the X-ray diffraction method, you can say Bragg's law. So from these topics, especially from the first unit, they will ask you questions. Now, the second topic here it is, material properties. Okay, you can take second topic here it is, material properties. From the material properties, they will ask you questions, especially mechanical properties of materials. Okay, mechanical properties, okay, like strength, hardness, ductility, toughness, resilience, proof resilience, creep, density. Like from these mechanical properties, they will ask you questions like sometimes basic questions, they will ask you sometimes basic numericals, like especially from true stress, true strain numericals, sometimes power law questions they may ask you for your exam. So here I am saying mechanical properties, mechanical properties. They'll ask you questions from the mechanical properties. Now, let us consider the third topic, that is very important topic for competitive exams and for ISRO also. This is very important topic, that is phase diagrams. Phase diagrams, especially from the phase diagrams, they'll ask you questions from iron cementite phase diagram, iron cementite equilibrium phase diagram, and from this like equilibrium reactions, you are familiar about these reactions like eutectic reaction, eutectoid reaction, peritectic reaction. The basic definitions they will ask you, like types of steels, hypoeutectoid steel, hypereutectoid steel, and types of cast irons, hypoeutectic cast iron, hypereutectic cast iron. This type of questions they will ask you from the phase diagrams. Okay, And also sometimes they may ask you questions from the phase diagram, the basic types of phase diagram, like or binary types, 3 types of binary phase diagram, basic meaning, isomorphous phase diagram, examples, eutectic phase diagram, examples, etc. But mostly they'll ask you questions from the iron cementite. So this is very, very important for exam. Okay, na? This is very, very important for exam. Now, let us consider the fourth unit. You can say the fourth unit is heat treatment. Fourth unit is heat treatment. Heat treatment. From the heat treatment, different heat treatment processes they will ask you. Theoretical questions they will ask you from the heat treatment, like what is hardening process, what is annealing process, and different types of annealing process are like pull annealing, process annealing, spheroidized annealing, diffusion annealing, then normalizing processes, normalizing process, tempering processes, like there are 2 types of tempering process again, high temperature tempering and low temperature tempering, and also the questions from the time temperature transformation diagram, like how the bayonet is produced as tempering process, Mach tempering process, and surface hardening processes like flame hardening, induction hardening, carburizing, nitriding, cyaniding. So this type of questions, from these they'll ask you the questions. Okay, from these they'll ask you the questions. So theoretical type of questions, theoretical types of questions they will ask you for your exam. Okay, na? So heat treatment, different heat treatment processes they will ask you. Okay, like you can say hardening, annealing, annealing, okay, normalizing, tempering, tempering, time temperature transformation diagram, then us tempering, Mar tempering, surface hardening operations. Remember, different surface hardening processes, and finally precipitation hardening. So they will ask you questions from these topics, especially from the heat treatment process, theoretical type of questions from these topics they will ask you. Right, these are the 4 topics. Then the 5th one you can take, okay, from the ferrous and non-ferrous alloys you can take. Ferrous and non-ferrous alloys. They'll ask you questions from the ferrous and non-ferrous alloys. So from the ferrous and non-ferrous alloys, what type of questions they will ask you? Like you can say types of steels and cast irons, types of steels and cast irons. Then non-ferrous alloys, like they'll ask you the questions from aluminum alloys, copper alloys. They'll ask you questions from the aluminum alloys, copper alloys, nickel alloys, okay, etc. They'll ask you questions, basic questions from this. So this is the 5th unit, ferrous and non-ferrous alloys. They will ask you questions. Then let us consider the 6th one. Some questions, rarely but not frequently, Rarely some questions they'll ask you from the polymers also. Okay, from the polymers especially they'll ask questions from two polymers. They are thermosetting polymers and thermoplastic polymers. Thermoplastic and thermosetting polymers. Thermoplastic polymers and thermosetting polymers. So, from the polymers topic, especially like examples of thermoplastic and thermosetting polymers, why it is reusable, then what type of polymerization mechanisms we are using in case of thermoplastics, what type of polymerization mechanisms we are using thermosetting. So, this type of questions they will ask you from the polymers. And sometimes and rarely they will also ask you questions sometimes powder metallurgy. Powder metallurgy. If you see from last 10 years, only 1-2 questions they asked from the powder metallurgy. It's a very simple topic. So, they will ask you questions from the basic steps, basic principles of powder metallurgy. Okay, basic principles of powder metallurgy they will ask you. Right. So, these are the topics. Out of these topics, if you remember, if you practice thoroughly these 4 topics, okay, more than 80% of the questions you can attempt. More than 80% of the questions you can attempt. The weightage, if you consider the weightage of this, weightage of material science for mechanical ISRO, weightage of this material science for mechanical ISRO is like you can say 6 to 8 questions they will ask you. It is also sometimes it is going to change. So, if you practice these 4 topics, these 4 units you can say, more than 50% or you can say more than 70% of the questions you can attempt. Because rarely they will ask you questions from the polymers and powder metallurgy. Okay, na? So, this is you can say the syllabus. Now, you can see the weightage of the material science. You can see the weightage of the material science. Now, see here the material science weightage you can see here. Now, you can take this the material science, right? Let us consider. I'll highlight this one. So, this is the material science. Okay. So, the material science weightage you can see. Okay. See, in 2006 3 questions, 7 5 questions, 8 7 questions, 9 8 questions, 10 8 questions, 11 5 questions, 12 7 questions, 7 questions. So, you can see in 2025 some 4 questions, 26 questions, 19 2 questions, 18 7 questions, like that randomly it is. So, what I am saying from this, so on an average 6 to 8 questions, maximum 8 questions, they will not go beyond that. So, minimum like sometimes 4 questions also they will ask you. So, this is the weightage related to the material science. Okay, na? Weightage related to the material science. Now, here I am going to discuss about the previous year questions of this material science topic. One by one we will discuss. So, first I will discuss the questions from the crystal structures and defects. From the first unit, I will discuss questions from the first unit. Now, you can see here, the defect responsible for the phenomena of slip by which most of the metals deform plastically is known as. See here, there are 4 options given, okay, 4 options given here. One option which is we will see the defect responsible for the phenomena. So, the defect responsible for the phenomena. So, here they are going to discuss about the defect. Here Fracture is not a defect, you can say it is a failure mechanism. Strain hardening is a strengthening mechanism. Twinning and dislocation, they are defects. So here dislocation is a defect that is responsible for the phenomena of slip, by which most of the metals generate plastic deformation, deform plastic deformation. So dislocations are the responsible for the plastic deformation. So C is the correct answer for this question. Okay, dislocations. Suppose if the dislocations are moving easily in a material, we can say they are more plastically deformable. If the dislocations they can't move easily, they are not deformable plastically, like that. Okay, based on the number of slip systems also you can guess the answer. Okay, na? So it's like number of slip systems, if it is more, you can say they are ductile metals, otherwise they are brittle metals. You can remember this one is also very important for exam, like structure and number of slip systems. Number of slip systems, structure and a number of slip systems you can take. Like for FCC structure, the number of slip systems are 12. BCC slip structure, number of slip systems are 48. HCP structure, number of slip systems are only 3. So you can say BCC and FCC metals are ductile metals and HCP metals are brittle metals, because they have less number of slip system. So the main responsible defect for the deformation is dislocation. Now let us consider the second one. This question is related to the Miller indices. Now see here, a plane intersects the coordinate axis at x equal to 2 by 3, y equal to 1 by 3, z equal to 1 by 2. So here what is the Miller indices of the plane? Miller index of this plane. See, listen, the coordinates axis magnitudes given. So plane fractions given. So plane fractions are, okay, plane fractions are what? 2 by 3, x equal to 2 by 3, y equal to 1 by 3, z equal to 1 by 2. So from the plane fractions, if you want to get a Miller indices, should do the reciprocals. So reciprocals of plane fractions. Now we take reciprocals of plane fractions. See here, 3 by 2, 3 by 1, 2 by 1. Now here there is a fraction. You should convert that fraction into the complete integer form. So Miller indices are okay, 3, 6, 4. I am multiplying with the 2. I am multiplying with 2. So 3, 6, 4. So this is the correct answer. So C is the correct answer for this question. 3, 6, 4. C is the correct answer. Right? Now, next question. Which of the following regions of the electromagnetic spectrum would be used to determine the structure of crystalline solids? See, the structure of crystalline materials are measured by using X-rays. Why are you using X-rays? Why not infrared rays? Why not visible rays, like that? Remember, there is a relationship between energy and wavelength. Energy is proportional to 1 by wavelength. If wavelength is more, energy is less. If wavelength is less, energy is more. So infrared rays, visible rays, UV rays, ultraviolet rays, they have more wavelength, so less energy, so they can't penetrate into the material. So these rays are not suitable. Then let us consider the low wavelength rays, like let us say alpha, beta, gamma rays. The alpha, beta, gamma rays, remember the alpha, beta, gamma rays, they have high energy but low penetration. They can't travel more distance. These rays cannot travel more distance. So that's why remember, we are not using this alpha, beta, gamma rays, but X-rays you can take. They have low wavelength, high energy, but they can travel more. They can travel more. That's why we are using X-rays. So C is the correct answer for this question. Remember, C is the correct answer for this question. Now let us consider dislocations in materials are. Dislocations are one-dimensional defect material. Okay. So line defect. Dislocations are nothing but line defects. They are one-dimensional defects. There are two types of dislocations: point defect and line defect. Sorry, edge dislocation and screw dislocation. They are two. Now, let us consider another question. Usually, materials with the following crystal structure fall in ductile mode, not fail, it is fall in ductile mode. See, I already said to you, remember, based on this table, you can say BCC, FCC metals are ductile, HCP materials are brittle. If the number of slip systems are more than 5, they are ductile. If the number of slip systems are less than 5, they are brittle. Good. Now listen, but here again, if you observe carefully this question, FCC is there, BCC is there, both are there. Both are there. Out of these two, which materials are more ductile? Which materials are more ductile? Usually materials with the following crystal structure fail in ductile mode, fall in ductile mode. It is correct only. Fail in ductile mode. Correct. So both are ductile materials. So HCP materials fail in ductile mode because they have low ductility. Okay, na? This is the correct answer. Low ductility. If they are written fall in ductile mode, FCC and BCC, out of FCC, BCC, FCC materials are more ductile. But as per this question here, it is given fail in ductile mode, HCP materials are fail in ductile mode because they have low ductility. Remember. Next, aluminum crystal structure is, comes under face-centered cubic structure. Remember, I'll give you the hint for face-centered cubic structure. I'll give you the examples of face-centered cubic structure. Face-centered cubic FCC structure you take. Okay, face-centered cubic structure you take. Now, in face-centered cubic structure, okay, you remember the example NALCO. Here N represent nickel, Al represent aluminium, CO represent copper. I'll give you more examples, some more examples. You remember a hint, face, FACE, face. So face of a human being, you can take the face of a human being, you can take like this. How will you beautify the face of a human being? How will you beautify the face of a human being? Ornaments, you can take ornaments. So ornaments are made up of gold, silver, platinum. So you can say gold is also comes under this category. Silver is also comes under this category. Platinum is also comes under this category. You can also take lead, tin, right? All are comes under FCC structure. Okay, na? Remember like that. Next, the structure which has the highest packing of atoms. So, out of these 5 structures, let us consider simple cubic structure, body centered cubic structure, face centered cubic structure, diamond cubic structure, HCP structure. The atomic packing factor for simple cubic structure is 0.52. Atomic packing factor 0.52. Body centered cubic structure 0.68. Face centered cubic structure 0.74. Diamond cubic structure 0.34. HCP structure 0.74 again. Now see here, the structure which has the highest packing of atoms. So highest packing of atoms, HCP structure 0.74, BCC structure 0.68, FCC again 0.74. So both A and C are the correct answer for this question. A and C are the correct answer for this question, D. Next, the effective number of lattice points in the unit cell of simple cubic, body centered cubic, face centered cubic, space lattice respectively. Now see here, let us consider the structure. I will give you the 3 structures here. Let us consider. In simple cubic, at every corner, one atom is located. In simple cubic, at every corner, one atom is located like this. This is simple cubic, right? So, if I consider effective number of atoms, the corner atom here it is 1/8 of the atom. So, like that 1/8 at every corner, like that 8 corner atoms, so 1. Next, let us consider BCC structure. Let us consider BCC structure. In BCC structure, remember, in BCC structure, okay, 8 atoms are located at 8 corners, 1 atom is located at the body center, like that, okay. 8 atoms are located at 8 corners, 1 atom is located at the body center. So, the number of atoms in BCC structure, if I consider, at every corner 1/8 of the atom, like that 8 corners plus 1 atom, so 2 atoms, right. Now, by using these two, we will get, see, remember, and yes, C is eliminated, D is eliminated. Let us consider out of A, B, you will get the answer B, because in FCC, the effective number of atoms are 4. The effective number of atoms are 4. That is B. B is the correct answer. Now, let us consider which of the following, remember, which of the following order of crystal structure will match with the metals of iron, copper, zinc in that order. See, iron is BCC structure, copper is FCC structure, zinc is HCP structure. Iron is BCC, copper is FCC, zinc is HCP. So, you can take respectively of the order BCC, FCC, HCP. So, this is the correct answer for this question. Okay. Iron is BCC, copper is FCC, zinc is HCP. D is the correct answer. Next, the crystal structure of cementite is, the crystal structure of cementite, remember, the cementite crystal structure is orthorhombic structure, straightforward question. The crystal structure of cementite is orthorhombic structure. The crystal structure of cementite is orthorhombic structure, remember, T. Then, knife line or hairline cracking is observed in, remember, it is a defect actually. The knife line or hairline cracking is observed in martensitic stainless steel. B is the correct answer. Number of atoms per unit cell of a face-centered cubic. So, the number of atoms in the FCC structure has 4. The number of atoms in the FCC structure has 4 number of atoms. C is the correct answer. Then, which of the following order of the crystal structure will match with metals iron, nickel, titanium in that order at room temperature? So, remember, iron is BCC, nickel is FCC, titanium is HCP. Same question repeated. So, BCC, FCC and HCP. So, D is the correct answer for this question. D is the correct answer for this question. Next, which of the following is an amorphous material? See, in amorphous material, remember, the amorphous material is also known as non-crystalline material. The amorphous material is also known as non-crystalline material. Okay. In non-crystalline material, atoms present irregularly, irregular arrangement of atoms. So, glass is a non-crystalline material. Glass is an amorphous material. Glass is an amorphous material. Next, which of the following is classified as a secondary bond in the materials? See, if we talk about the bonds, ionic bond, covalent bond and metallic bond, these are primary bonds. All these are primary bonds. Ionic bond, covalent bond and metallic bond, they are primary bonds. Hydrogen bond, van der Waals bond, these bonds are secondary bonds. Okay, hydrogen bonds, van der Waals bonds, these bonds are secondary bonds. So, D is the answer for this question. Secondary bonds they are asking. Next, the number of atoms per unit cell of an FCC crystal structure. See, third time this is asking. FCC crystal structure, the number of atoms inside the unit cell is 4. Effective number of atoms are 4 because at every corner one atom is there. So, inside the unit cell at every corner 1 by 8 like that 8 corner. At every phase center 1 by 2 of the atom is there like that 6 phase center. So, that 4 atoms you will get inside the unit cell. Next. So, these are the questions they asked from last 5-10 years from the crystal structures. They are very easy questions, right? Now, the next topic, that is second topic I am giving, material properties and testing. Okay, material properties and testing. Now, we can see what is this question, what is this question? Materials exhibiting time bound behavior are known as time bound behavior. We can say they are viscoelastic materials. Viscoelastic materials. Okay, na? A is the correct answer for this question. A body which is permanently deformed is said to be have undergone plastic deformation. Okay, they have plastic deformation. Plastic deformation is nothing but a permanent deformation. C is the correct answer. In a hardness test, L is the load in kg, D is the diameter of ball in mm and small d is the diameter of indentation in mm. Brinell hardness number. Remember, in case of Brinell hardness test, suppose if this is a workpiece, this is a mandrel, okay, at the bottom of the mandrel, this is an indenter tool. This indenter tool has a diameter small d. Now, if we apply the force, suppose L is the force they applied. This is the diameter, that is capital D. Capital D is the diameter. Once if you apply the force, it is going to penetrate like this. So, this will give you small d, that is indentation diameter. Capital D is indenter tool diameter, small d is indentation diameter. Now from this, Brinell hardness number is equal to L is the force applied divided by pi by 2 into d minus under root capital D square minus small d square. So, if you bring this into the numerator, it will become 2L, so that Brinell hardness number, this is the answer. Okay, na? This is the one. B is the correct one. Next, proof resilience may be defined as proof resilience is the energy of material absorbed by the material up to the elastic limit. Suppose let us consider this is a stress strain curve. If this is an elastic limit, now energy absorbed by the material up to the elastic limit, we call it as proof resilience. Now see here, maximum strain energy that can be stored in a material per unit volume, maximum strain energy that can be stored in a material under elastic condition. So this is the correct one. Elastic condition, C is the correct answer. Okay, na? C is the correct answer, because here it is given elastic condition. Next question, it's a match the following question. See, remember, match the following questions: malleability, hardness, resilience, isotropy. Here, wide drawing, impact loads, cold rolling, indentation and direction. See, isotropy means the material properties are same in all directions. So, D is 5. So, out of this, A is eliminated, B is eliminated. Next, malleability is nothing but making into thin sheets. So, this is. Then hardness is nothing but indentation, B is 4. Resilience is nothing but impact load, you can say impact load resilience. So, you can take B, A is 3, D is 5, B is 4. So, B is 4 and C is 2. So, this is the answer. B is the correct answer for this question. Now, the engineering and true strains for a bar which is doubled in length during tension test. Now, listen, let us consider initial length is L, final length is 2L. Now, engineering strain is what? Delta L by L, that is 2L minus L by L, that is L by L, that is 1. Then let us consider a true strain, that is Ln, final length by initial length, that is Ln 2L by L, that is Ln2. That Ln2 value is 0.693. You should remember for exam. For competitive exams, they will ask you. So, here A is the correct answer for this question. A is the correct answer for this question. Next, when a material sustains steady loads for a long periods of time, the material may continue to deform until they may tend to fracture under the same load. This phenomena is known as creep. This is, we call it as creep. Creep is the answer. Next, see, match the following question here: resilience, fatigue, stiffness and elasticity. See, ability of material to return to its original shape when the load is removed, elasticity, D is 1. The capacity of a material to absorb energy elastically, resilience. Ability of material to absorb certain amount of energy without failure, we will see that. Resistance of the material to elastic deformation, stiffness and fatigue, you can take this one. So, 2, 3, 4, 1, you can say, okay, 2, 3, 4, 1 is not, okay, 5 is also there, huh? Okay, I forgot. Failure of material at loads less than that the normal condition you can take, this is 5. Fatigue is a type of failure due to dynamic loads, fatigue loads, right? So 2541, 2541, 2541 D is the correct answer for this question. Next, modulus of resilience for which the material below material. See, modulus of resilience is area of stress strain curve, this area. So half into stress into strain. So you can take 100 Newton for mm square, okay, Newton for mm square. That means you can say you can multiply with 10 power 6, you will get Newton for meter square, megapascal it is, megapascal. So if you convert that, so no need to do calculation, directly you will get 100 you will get, right? B is the correct answer. Which of the following is a true for ductile material? Ductile material. Engineering stress strain curve cannot have negative slope. Most applicable failures. Theory is maximum principal stress theory. Ultimate strain is the strain at ultimate stress. Strain hardening is represented by a negative slope in engineering stress strain curve. Remember, which of the following is true for ductile material? See, for a ductile material, if I consider, it is like this. It is a negative slope is there here. Negative slope. So strain hardening is represented by negative slope in the engineering stress strain curve. So D is the correct answer for this question. Okay. No, cannot be having a negative slope here, positive slope only, because strain hardening, remember this is the strain hardening region, sigma is equal to K into epsilon T power n. This is a negative after ultimate point, that is. So you can take A, you can take it as correct one, right? Now, a material that exhibits the same elastic properties in all the directions, that is known as isotropic material. C is the correct answer, right? The impact strength of a material is an index of its impact strength, toughness. Impact strength, toughness is the ability of material that can absorb energy up to the fracture point. Next, which of the following hardness tester uses diamond cone? Diamond cone is used in, you can say, diamond cone shaped diamond is used in Rockwell. Remember, Brinell test we are using spherical, sphere. Vickers pyramid, Knoop also pyramid. This is cone. Remember, that is cone. Next, see, beach or clamshell marks on a failed metallic surface are a typical. Clamps metallic, beach or clammed metallic failures are occurred in the brittle fracture, you can say. B is the correct answer. So these are the questions related to the material properties and testing. Now, next come to the phase diagrams. Phase diagrams questions. Now you can see, hot working operation is carried out above recrystallization temperature. Hot working operation is done above recrystallization temperature. Work hardening, strengthen an alloy of removing internal defects, not correct. Increasing the dislocation density is correct. Work hardening is nothing but strain hardening. So by increasing the dislocation density, dislocation moment is arrested, strength of metal is increasing. A material is dimensionally stable at room temperature if its glass transient temperature is just above the room temperature. So remember, glass transient temperature is what? Below glass transient temperature metal is brittle, above glass transient temperature metal is ductile. So if the glass transient temperature is above room temperature, then at room temperature material dimension is stable. So B is the correct answer for this question. Now, a mixture of chemical compounds or elements that have single chemical composition and solidifies at the lowest temperature than any other composition made up of the same ingredients. Phase balanced system, Utex system, binary, thermally balanced system, intrinsic system. See, mixture of chemical compounds are elements that have single chemical composition and solidifies at lowest temperature. Solidifies at lowest temperature, okay, than any other composition, lowest temperature than any other composition of the same ingredient, we can say binary thermally balanced system, you can say. Okay, now an eutectoid steel consists of perlite and cementite. Okay, now next question, when a material is strain hardened, its yield strength increases and ductility is going to decrease. Its yield strength increases and ductility is going to increase, right? Now, which one of the following steel contains least percentage of carbon? Mild steel contains the least percentage of carbon, okay, least percentage of carbon. The reaction in which a liquid phase transforms into two different solid phases, like, so liquid transforms into two solids, you can say it is a eutectic reaction. It is a eutectic reaction with a eutectic phase diagram. Now, in a two-component system, if the non-compositional variables only temperature, the number of degrees of freedom in this of a single phase solidified as per the Gibbs phase rule. See, as per Gibbs phase rule, only temperature is a variable, this is the one, right? Components are two, phase is only one. If I take now F plus 1 is equal to 2 plus 1, so degree of freedom is 2. So, degree of freedom is 2. C is the correct answer. Now, an iron carbon diagram, the percentage by weight of a carbon at eutectoid composition. So, eutectoid composition is 0.8% of carbon, you can say 0.76. Next, the questions from the heat treatment. So, phase diagram questions are very basic questions. Now, we can see hardness of steel depends on what? Hardness of steel depends on amount of carbon it contains. Remember, if we increase the carbon content in the metal, cementite formation increases, so hardness of the material automatically increases. So, that is A is the correct answer for this question. Which of the following has maximum hardness? See, out of these, the martensite has maximum hardness because here we are producing this one by quenching in water. Because of quenching in water, you will get maximum hardness. Then, which is false statement about annealing? Annealing is done to, remember, annealing is done to relieve the residual stresses, to increase the ductility, to increase the toughness, to reduce the strength, to reduce the hardness, right? Now, see here, annealing is done to relieve stresses, correct? Harden the steel, slightly wrong. Improves machining characteristics, correct? Soften the material, correct? So, which false statement is about annealing? False statement they are asking. So, harden steel slightly. Harden steel slightly is wrong. B is the answer. Next, induction hardening is a process of. Induction hardening is a process of what? Induction hardening. Induction hardening is a flame hardening model, like we are using induction coil to increase the surface hardness. So, hardening of surface for wear resistance. Hardening of surface for wear resistance, that is induction hardening. Which one is not the purpose of heat treatment of steel? Remember, is not the purpose. You will see, changing the composition of steel on the surface, okay, changing the percentage of carbon and silicon in the bulk, increasing or decreasing the grain size, removing undesirable residual stresses. So this is not the responsible, this is not the purpose. Changing the percentage of carbon and silicon in bulk. Changing the percentage of carbon and silicon in bulk. So B is the correct answer for this question. B is the correct answer. Now, materials after cold working are subjected to the following process to relieve stresses. Materials after cold working are subjected to the following process to relieve residual stresses, that is annealing. Remember, we are using annealing operation. D is the correct answer. Now, precipitation hardening is applicable for, see remember, precipitation hardening is a heat treatment process. It is mainly applicable for non-ferrous alloys like aluminum and copper alloys. Aluminum, copper alloys. Which of the following statement is false about annealing? Annealing is done to harden the steel slightly. It is not correct. Relieving, softening, permit further cold working. So this is false statement they are asking. Read the question carefully. False statement they are asking regarding annealing. Okay. Now, the essential ingredient of any hardened steel is, the essential ingredient of any hardened steel. Hardened steel means by quenching the material in water you will get, that is called martensite. That is known as a martensite. Martensite is the correct answer for this question. Next, what is the common surface hardening treatment in steel? Common surface hardening is carburizing, nitriding, cyaniding, polarizing, flame hardening, induction hardening, all these are surface hardening methods. Hardness will be highest after which of the following heat treatment process? Remember, there are furnace cooling, air cooling, oil quenching and water quenching. By quenching the material in water, fast cooling rate, rapid cooling rate you can see, so that hardness you will get highest. Which of the following treatment does not improve hardness? See remember, by quenching hardness increases, cyaniding hardness increases, normalizing also up to certain limit you can increase, but annealing will not increase. Annealing will not improve, does not improve hardness. So D is the correct answer for this question. Next, which one of the following is false about polarizing? So polarizing is also a surface hardening process, right? See, it is a pack cementation process. It can be done only on high carbon steel. It is used to obtain extremely high wear resistance surface on steel. It leads to high distortion. So remember, false about polarizing. False about polarizing. It can be done only on high carbon steel is not correct. Because polarizing is a case hardening process used for low carbon steel also especially. So B is wrong. B is wrong. Next, the process of reheating the martensitic steel to reduce its brittleness without any significant loss of hardness. Reheating, that is nothing but tempering operation. By to relieve the residual stresses, we are applying tempering process. So B is the correct answer for this question. Next, of the various microstructures that may be produced for a given steel alloy, which among the following is the hardest form? Martensite is the hardest form. A is the correct answer for this question. A is the correct answer for this question. Right? These are the some of the questions related to the heat treatment. Like that, there are so many questions. There are so many questions. I am covering within this 1 hour. So many questions I covered. You go through our ACE booklet, ISRO questions we are providing, previous year questions. You will learn, you will get to know lot of information. And thanks for watching this video. All the best for your exam.